Now, what is the reason behind these angles? In first case we have 20 degree and another case we have 6 to 8 degree only. Now, since we have understood what is boundary layer separation with the help of video, so I would like to develop this concept to understand this variation of angle. We know that flow cannot be separated in converging passage. Why? Because area in converging passage is reducing, area is reducing. When area is reducing, then what happens to velocity? This velocity goes up, this velocity goes up, velocity increases for same mass flow rate or same flow rate with the help of continuity equation. When velocity goes up, it means that to keep P over rho g plus V over 2g as constant, there must be P over rho g must be reduced. If V square over 2g is increasing in the downstream side, then P over rho g must be reduced. So, it means that on the downstream side the pressure is reducing, decreasing, pressure is decreasing. So, it means that fluid is flowing in a zone where we have a negative pressure gradient, pressure is continuously decreasing. This is called favorable pressure gradient condition, pressure is decreasing. But in this case of diverging portion, what happens that at different cross section in the downstream side, the area is increasing. When area is increasing, in that case what happens to velocity for same mass flow rate? With the help of the continuity equation, velocity decreases. When velocity decreases, it means that P over rho g increases. It means that on subsequent section this pressure is increasing. When pressure is increasing, it means that we are moving or fluid is moving in a zone where it is interacting with higher pressure. So, whenever fluid moves in a zone where the pressure is increasing, in that case there is a possibility of separation. Separation always happens when dP over dx is greater than 0 or positive. When dP over dx is positive, then only we have the possibility of separation. Right. And whenever we have a separation, separation means rolling back of fluid particles, then large energy is lost, and Venturimeter or any device which is used for measuring the flow rate should be designed in such a manner so that it consumes less energy and at the same time it can measure accurately. But if it is consuming more energy, then it is not suitable device. So, to avoid separation, what we do, we keep this angle less. By keeping this angle less, the severity of dP over dx is reduced. So, if severity of dP over dx is reduced, then the possibility of separation is reduced. We can understand with another figure. Suppose we have a hill here. This is the 2D diagram of hill, right. If we hit a footwall from this side, it moves up to this point, and if it does not have sufficient energy to move up to top, then it will start rolling back. So, rolling back of footwall in this direction is basically is assumed to be that flow is separated. But if you hit a just footwall in this direction, then this footwall will keep moving in this direction. There is no question of rolling back of footwall in backward direction, it will move only in forward direction. So, if we have one kind of hill like this, and if we have another kind of hill where as such the top line means height of the layer is same, but if we make it like this, in that case the severity of gradient is reduced. So, by keeping this angle less, we reduce the severity of gradient. Dp over dx is greater than 0, this severity is reduced. So, possibility of separation is reduced. So, that is why the diverging portion angle is kept 6 to 8 degree, which is less than the converging angle 20 degree. Though by reducing the angle, what we do, we increase the length to achieve the same diameter, right. We have increased the length here, and whenever length is increased, we know, or we will be studying in our subsequent lecture, that whenever this fluid has to travel more distance, then there will be loss, like this is called frictional loss, because whenever a fluid, real fluid flows in a pipe, then there will be frictional loss, and to overcome the frictional loss, there will be some pressure loss, right. So though pressure loss is increased if you keep increasing the length, so if you decrease this angle by 1 degree say, or 0.1 degree, then this length will keep increasing, and this device will start consuming more and more energy due to the frictional loss, right. So that's why there is optimization, that we keep it 6 to 8 degree, right, to avoid the separation, at the same time to not to increase the frictional loss due to the length of the pipe. So after understanding the basic principle of the Venturimeter, that is the, by changing the area we create the pressure difference, and that pressure difference is measured, and that pressure difference is related to the flow rate. We will understand and we will develop the mathematical relationship